I was surprised and flattered to learn that Harvey Mudd students had selected me to be their commencement speaker. Now, there are three basic options for a commencement speech. The best is funny and entertaining, but I'm a physicist, so I don't do funny. And if I ever did, spending 2 years in Washington, D.C. killed it. When you see how the government really works from the inside, you have to either laugh or cry, and mostly I cried. So if you can't get funny, the next best commencement speaker is charismatic and inspiring. But I did say I'm a physicist, right? So we can cross off the charismatic option. So that leaves a third choice, which is to tell you something useful, your final dose of learning at Harvey Mudd, as it were. But, that's not so easy. All you graduating students have worked so hard for so long. You must have learned everything by now, right? And certainly, with what you parents had to pay for their education, your children had better learned everything by now. But what have you really learned, and how is it going to be useful to you? This question gets at the nature of expertise in science and engineering and how it develops. And that's what I've been studying for the past couple of decades, because it's really at the heart of science and engineering education. Now, if you start by looking at the knowledge that practicing scientists and engineers use in their daily work, and you compare that with what they learned in school, it turns out they only use a tiny fraction of what they learned in school, maybe like 10%. And conversely, all that information and techniques they learned in school, they only use about 10% of it. Now, at some level, this shouldn't really surprise you because science and engineering fields are moving so rapidly that what you know today will be at least partly obsolete in just a few years. But on the other hand, those numbers sound pretty terrible. It sounds like I'm saying that 90% of all that work you students did and 90% of all that tuition was largely wasted. I did warn you I wasn't going to be inspiring, right? However, I'm not really saying that. That was wasted. Instead, I want to share some thoughts with you about what you have learned that goes beyond the specific pieces of knowledge you've gained and, in fact, is the real value of your education. This is about how expertise develops and hopefully can help you better understand exactly what you've actually learned and how you learned it, and that'll allow you to use this learning better in the future and be more effective at building on it, at whatever you choose to do. Now, so what researchers have learned is that reaching a certain high level of expertise, and by level of expertise, I mean the degree of which a person can think like and solve problems like a very high-level expert, whether that's a practicing physicist or an engineer or biologist. That level of expertise is really not about having taken a lot of courses and covered a lot of topics. Acquiring expertise is actually a process of brain development that only comes about through strenuous and prolonged exercise of the brain in the right way, practicing expert thinking. And so just like a muscle that develops when it's used strenuously, when the brain's pushed hard, it responds by changing and getting better. And similar to a muscle, it's that process of putting great demands on it that cause it to respond and improve. And that using either a muscle or your brain at some low level doesn't really have much effect, even if it's done for a very long time. So there's real value in all that very hard work that you did, that straining to make sense of those strange ideas at 2 o'clock in the morning. Your brain's literally grown and rewired itself as a result so that it's different and better with new capabilities that it didn't have when you arrived on campus. We can actually see those changes now with new brain imaging techniques. But what are those capabilities of your upgraded brain? I mean, at the simplistic level, it means better problem solving. But looking in more detail, what it might mean, it first means you have a whole new mental framework for organizing all your knowledge so that when faced with a new problem or question, you can quickly figure out which of that knowledge is useful and apply it appropriately. Also, your brain's now wired to recognize complex patterns and relationships and concepts that guide you in solving problems and creating good designs. Finally, it also means you have the capability to test if you understand something, or an explanation makes sense, or your solution to a problem or a design is good or not, and then change what you're doing accordingly. This capacity to evaluate one's own thinking is actually one of the most important and overlooked aspects of expertise. It really develops only through practice and largely through interactions with your peers. Now, when researchers study people who have reached very high levels of expertise, they find it takes about everyone about 10,000 hours of this intense, concentrated mental effort to become a world-class expert in pretty much any established field, including all those in science and engineering. Now, if you add up the number of hours you've spent studying intently at Harvey Mudd, and I'm assuming you're all thinking and calculating that, my estimate it's actually less than 10,000, but you've actually done a pretty hefty fraction of that 10,000 now. So you're not done, or at least you're not as good as you can be, and likely will be one day, but you're well on the way. You've acquired a lot of expertise, your brain's a lot better than it was when you started 4 years ago, and you're able to do a lot that you couldn't do before, and you have a very solid foundation and framework of expertise to build on. This number 10,000 hours in itself is kind of interesting. People who are judged to be very talented early on, after they've put in this 10,000 hours of intense practice, they reach a very high level of expertise. But people who are judged to not have much initial talent, after they put in 10,000 hours of intense practice, they're at the same level. So it doesn't take them any longer. So although our society tends to see talent, particularly in things like math and science and engineering, whatever they mean by talent, they see that as sort of crucial to success in those fields. The research says this is actually much more perception than any reality. What the research shows really counts in achieving high-level expertise, and the accomplishment that comes along with that is the ability to keep pushing yourself hard to learn more and get better. Now, I certainly noticed this in my own case. I came from the backwoods of Oregon, and when I arrived at MIT, it seemed like everyone was smarter than me. I struggled and actually did quite badly in my first physics course, and by most any measure would have said I didn't have much talent for physics. It seemed like everyone could understand it easier than I could. But one thing I was as good or better than anyone else was working hard and pushing myself to learn. So after a year or two, it seemed, gee, maybe most students weren't all that much smarter than I was. And by the time I got to graduate school, it was pretty clear that I'd put in more hours thinking hard about physics and studying physics than most of them, and they were starting to come to me with questions. And eventually, I reached the point where, and I actually remember this thought hitting me quite suddenly during a discussion at a physics conference 5 or 6 years after I finished graduate school. I suddenly thought, when did all those smart people get so stupid? Because, there were things that were clear to me that almost none of the other physicists in the room seemed to get. And Now, the reality, of course, was not that they'd gotten stupid, but that I'd gotten a lot smarter, at least in terms of atomic physics. Now, this changed perspective, as reflected in that comment, is actually an important thing to keep in mind, particularly if you go on into teaching, and at some level we all end up as teachers. And because what it really comes from is the fact that your brain, really has no independent reference. And so we automatically always think our brain's the same, but it's not. So if you're working with some student and they're struggling to understand something that seems simple and obvious to you, it doesn't mean they're hopelessly stupid, and it also doesn't mean the topic was always simple and obvious to you. People routinely fool themselves in that respect. Their memories of how hard something was and how they learned it are usually wrong when you actually have a way to go back and check those. Just like I thought that lots of physicists had gotten stupider. So as a teacher, it means that you need to work hard to understand what stage that learner's brain is at and give them the guidance they need to work effectively to master the subject and the process of making their brains better. And I trust that's what most of your teachers have done with you here. Now, from all that I've heard about Harvey Mudd graduates, in addition to you improving your brains, you've learned that most important of all skills, how to push yourselves hard to learn more. And hard doesn't mean unpleasant, and in fact, at your level, it really shouldn't be unpleasant from now on. Because we all know that the things that are most satisfying to accomplish are those that are most challenging, and that as one more deeply appreciates the value of mastering something, the more you actually know about the subject. So if you have a deep appreciation for some particular area of science and engineering, then deepening your learning and expertise about those subjects further should be becoming more worthwhile and rewarding to you. So finally, to summarize, that the actual learning that you graduates have achieved is far more important than any particular set of topics and techniques. It's basically, first the expertise and the better brain that goes along with it that you've developed, the ability to work hard to learn new things, the satisfaction and confidence that comes from tackling very hard intellectual challenges and mastering them, and finally, it's appreciating the richness and the challenges and the opportunities in science and engineering. So these are the things that you've learned that will make you successful in the years to come, long after you've forgotten what a Wronskian is. Thank you, and congratulations.